Hi everyone, my name is Pratiksha Kawale and today I am going to demonstrate my DMW project, which is email spam detection. Email spam, also called a junk mail. So let's see the output of the program first. And the program detects email messages as spam or not spam. So let's enter a text. So this text looks like spam text. So let's see what it will predict.
This is a spam mail.
So this is a spam mail. Let's try for another example. We are about to make a statement.
This is not a spam mail.
So this is not a spam mail. Now we will move to the actual code. First step is to import the libraries. Here I have imported the library pandas, which is used for data analysis, and sklearn, which is used to build machine learning models, which contains efficient tools for machine learning and statistical modeling, including classification, regression, and clustering. Then the next step is to load the dataset and print the first 5 rows and last 5 rows of the dataset. This readcsv command loads the dataset. Head returns the first 5 rows of the dataset and tail returns the last 5 rows of the dataset. Then let's explore the dataset and get the number of rows and columns. The new shape of the dataset is 5728 rows and 2 columns. And these 2 columns are named as text and spam. Then dot duplicates checks for the duplicate values and removes them. After removing the duplicate values, the new shape of the dataset is 5695 rows and 2 columns. Then checking for the null values in the dataset for each column. Then count vectorizer is imported from the sklearn.featureExtraction.txt module. This module can be used to extract features in a format supported by machine learning algorithms from datasets consisting of formats such as text and images. And count vectorizer implements both tokenization and occurrence counting in a single class. Then the instance of the count vectorizer is created. This X stores the independent feature, that is text, and the Y stores the target feature or the dependent feature, that is spam. Then this count vectorizer.fit transform fits the count vectorizer model and returns sparse matrix of count of tokens in each given sentence. For example, there are 3 sentences: the sun, the moon, and the earth, and this is the sparse matrix for it. In sparse matrix, each distinct word is represented by a column of the matrix, and each sentence is a row in the matrix. And the value of each cell is nothing but the count of the word in that particular sentence. Here, these distinct words are the columns of the matrix, and the sentence number are the rows of the matrix. Then the shape of our sparse matrix for our dataset is 5695 rows and 37,303 columns. That means that 37,303 distinct words are present in our dataset. Then data is split into training data and testing data. The training feature dataset will be stored in xtrend, and the feature training target feature dataset will be stored in ytrain, and the testing feature dataset will be stored in xtest, and the testing target dataset will be stored in ytest. For training, I have used 80% of the data, that is 4,556 rows and 37,303 columns. And for testing, I have used 20% of the data, that is 1,139 rows and 37,303 columns. Then the multinomial naive-Bayes classifier model is created. The multinomial naive-Bayes classifier is suitable for classification with discrete features. This model fits the model on xtrain and ytrain. Then next step is to evaluate the model on the training dataset and the testing dataset. The model accurately identified the email messages as spam or not spam with 99.67% accuracy on training data and 99.12% accuracy on testing data. Then these two files are created in write mode for the front end part of the project. And this is the code for the front end part. So this is the text, and the model predicts it as 1, that is represented as spam mail, and the next text is predicted as 0, that is this is not a spam mail.